So far we've learned actually many ways of solving quadratic equation, right? Does anybody remember one of the ways we used? What was one of the ways that we used to solve a quadratic equation? Yes? Quadratic equation. Quadratic formula, right? Quadratic formula, you're right. Secondly, yes? Completing the square. Very good. Third method we learned? Yeah. Factoring. Remember, like back in chapter, whichever, right? We learn how to factor. Lastly, we learn how to? Yeah, right. Discriminant is just looking into, discriminant tells you how many roots you have. Right? So that's not actually a way of solving quadratic equation. It tells you what the graph of this quadratic equation look like. Right? So what's the third method? Do you guys remember when you had x squared on the left side, you square root both sides? What is that called?
Oh,
yeah, you square root both sides, right? You could use, okay, so you basically, if you have a perfect square on the left side and it equals some number, you square root both sides, right? That's one. So then when I give you on the test, do you think I'm going to necessarily tell you which method to use? No. If I give you some quadratic, some I will say use completing the square or something. But some parts of the test will say just solve. And you have to decide which methods to use. There are 4 methods that we have learned. Now some methods are a little bit easier than the other. Now which method works every time? Quadratic equation, right? Quadratic equation. I mean, I keep saying equation. Quadratic formula would always work, right? But do you necessarily want to use that every time? No, because there are some cases where you might want to use some other method. Can somebody think about when you might use some other method? Yes? When you have difference of squares? What do you mean?
Like there's 25x squared minus 25 equals 0.
Oh, so if you see on the left side, then you could factor, right? Okay, then you might just want to use factoring. Why? Why would you want to? Why not just use quadratic equation? Why would you want to just factor? Jay?
Because you have to plug in different amounts, then you might have to do more work with the quadratic.
Yeah, in other words, it may take a little longer than just factoring. Does that make sense? But if you ever get stuck, you could always rely on quadratic formula. Right, guys? Very good. So if you could factor, right, then you might want to just use factoring method, right? That's one of the methods we learned. When else would you like? Is there any other time when you might want to use something else, some other method, other than quadratic or factoring? Yeah.
If you have a square root on both sides.
Square root, or if you square, yeah.
Square.
If you have a square, like if you have x squared is equal to 4, are you going to use quadratic formula? No. Okay, you could. What if you have x squared is equal to 4? What's your a? 1. What's your b? 0. What's your c?
0.
Okay, so you could use it, but I mean you just square root both sides, right? Yes. And there are some other cases where you might want to use like, can you think of any time where you might want to use completing the square method? Have we mentioned this by the way? Yeah, that's one, completing the square method, right? That's one of the. Okay. When might you want to use completing the square method? Yeah.
In any case that you don't want to do the work for the quadratic formula.
Yeah, actually that's true because how do we get quadratic formula? By completing the square, right? So there are times where you might want to use it if you feel comfortable, but I know some of you probably won't. but I'll show you some instances where it's easy if you remember how to do it, and it's not too bad, right? It's that coefficient of the middle term. Oh, you gotta make sure a is 1, and then you square the half of the coefficient of the middle term and you add it to both sides. Remember? Yeah. Question?
On the test, will you say you have to use this method?
Yes. So there are parts where yes, I'm going to ask you to use all these 4 methods. I want to know whether or not you know how to do all these 4 methods.
Oh.
But there are parts of the test where I will just say solve, and you have to decide which method is most appropriate. That's why we're talking about methods of solution.
Awesome.
Okay. So as you have your worksheet, let's first method that I want to talk about, and it says method on the left side, and it says when to use this method. Right? Does that make sense? So we're going to talk about when might be the best time to use this method. Is that okay? So first method I want to talk about is, of course, factoring. Okay, factoring. So it says if an equation is in this form, which form would you like to have the equation to look like? Sarah? Equals to 2? First of all, on the right side, it has to equal to what first? If you're going to factor, it has to equal to 0. So, must be able to factor the trinomial that equals to 0. If you know how to factor a trinomial that equals 0, if you have that form. So actually, there's another form I want to talk about. In other words, in the box. So method 1 is factoring. And when do you want to use? Must be able to factor the trinomial that looks like this on the right. Yeah, this is when you want to factor, right? If you know how to factor a trinomial that equals to 0, then you just factor. Isn't that the easiest way? Okay. Here's an example. You might want to, if you want, you could write the example on the left side, because you might have some more space. So, like this. If I have x squared plus 7x plus 12 equals 0, especially when the first coefficient is 1, right, leading coefficient 1, it's easy, right, to see whether it factors. Anybody know how to factor this? In other words, what can you multiply? You get 12, and then since the coefficient of the leading term is 1, and when you add, you get 7, yeah.
X plus 3.
Yeah, x plus 3 and?
X plus 1.
Yeah, so you see, if you could factor this, you just use factoring, right? And we know what the answer is. What makes this true? This is you don't have to write this down, but I'm just giving you an example. What I mean by this, right? When the trinomial goes to some thing equals 0. So the answers, you have two answers. When is this true? Using zero product property when x equals to -4 or -3. Okay, there we go. Okay. There's actually another case where you really should use factoring method, and I'm not talking about this sort of factoring. I'm talking about using GCF and so forth. Anybody think of case? Write this down. You might want to really write. When c is equal to 0. What I mean by that is if I have ax squared plus bx equals to bx plus c equals 0, if the c happens to be 0 in this form, you really should factor. Because that is going to be really, really easy to factor and figure out the answer. Anybody see why? One person see it? Two? Go ahead, think about with your group. Why would you want to say, in other words, if c is missing, right? If you have only two terms with a x squared term and then bx, right? You don't have that constant term, you should always factor. Think about this. Go ahead, talk to your group. You should really factor when you have this. Why? Why would you want to do this? Who thinks they know why I said you should definitely factor when c is equal to 0? Two people? That's it? Oh, Robert, what do you think?
Well, when c is 0,
Mhm.
you factor the x.
Yeah, you could always factor out the x, right? Isn't that one of the easiest way to factor? Factoring out your GCF? Your x, the x will be always your GCF, right? So, like for example, if I have something like this, you see my c is not there, right? And it equals to 0, right? The whole equation. So, look, on the left side, we know how to factor the left side. You have GCF of x. You would always have at least the GCF of x, right? That's guaranteed, right? When c is equal to 0. Therefore, do you know how to then figure out the answer? When is this going to be 0? Using zero product property, J. Is there only one person? John?
X equals 0 or x equals -2/3.
Yeah, when x equals 0, don't forget that one, right? If x is 0, the whole thing is 0, right? Remember zero product property? If one of the factors is 0. And of course, when will 3x plus 2 be 0? Well, subtract 2 from both sides, divided by 3. So, right here, right? So there are two cases, right? Two cases. Either -2/3 or 0. You see how easy would that be? So do you think you want to use a quadratic formula for this one? You could, but it'd be a lot easier, right? No, seriously, but when you don't know how to do any of these, you could always, right, turn to quadratic formula. It'll always get you the right answer, right? Isn't that nice? It just takes a little longer than the other method. Okay. So there are two cases where you might want to factor, right? So first case is if you have a trinomial that you know how to factor. Oh, first of all, you have to make sure the equation equals to 0, right? That's what you got to check first, right? Then if that trinomial on the left side is factorable, you factor. Or if the trinomial on the left side, after you made it equal to 0, has no constant term. In other words, when c is 0, you could always factor out dx. Yeah, question?
When you do the quadratic formula, it'd be 2/3, right?
Mhm. Yeah. No, you get two solutions, 0 or negative.
I mean 2/3. You're gonna divide both.
No, for the, no.
You divide.
Do we have to divide both sides by 3 in order to use a quadratic formula? No, quadratic formula does not
Mine
require
goes
for you to have,
equals negative b plus or minus.
yeah, your A is 3, your B is 2, your C is 0.
Oh, it's for the.
When do we want the leading coefficient, the coefficient of the leading coefficient to be 1? When is, Michael says, don't we have to divide both sides by 3 in order to use a quadratic formula? The answer is no. Quadratic formula doesn't have, all you have to do is,
That other formula is like.
yeah, that's when. When do we use this? Yes, Mane? Completing the square. If you're going to complete the square, that's what you do.
Oh.
For quadratic formula, you just use ABC, right? Of course, you have to make the whole thing equal to 0 first, right? Then you figure out your ABC. In other words, you have to write this in standard form for quadratic equation. Does that make sense, Michael?
Yeah.
Yeah, for quadratic formula, that's why it's nice. You don't have to do anything except making the whole equation equal to 0, and then use ABC, and then you just plug it in to the formula. Yeah?
Does this go in the second box or the first box?
This goes into first. We're still in the first. Sorry, I should have made this a little bit bigger. Okay, number 2. The next method I want to talk about is, after you see a trinomial you can factor, second thing you should think about doing is square rooting both sides, if it works, okay? Or, I mean, it just depends. So you square root both sides, and I put plus or minus. Why do you think I put plus or minus there?
So you make the plus or minus.
Yeah, whenever you square root both sides, you must put what? Plus or minus where the number is, right? You guys remember? So you should really remember that. So whenever you square root both sides, remember the plus or minus, okay? Okay, when do you think you want to use this method? Jay said you have to have square both sides?
Perfect square on both sides.
Do you have to have perfect square on both sides?
No, you just have to have it on one side.
One side where the x is, right? Does that make sense? So here's what I wrote down. The whole side of an equation with the variable is squared equal to some number. In other words, like this. You have something squared equals to some number, basically, right? If you have this, do you think you want to use a quadratic formula on this one?
No.
Why not? If you had to use quadratic formula for this, what would you have to do? Yeah.
You have to make it into a trinomial.
Yeah, you would have to make it into a trinomial. You got to multiply x minus 4 times x minus 4 and then subtract 3 from both sides so it equals to 0. Then figure out your ABC and then plug it into the formula. That would be too long. But since the whole side on the left side, right, where the x is squared and it equals to some number, all you have to do is what, class? Go ahead, everybody, solve this one. All we have to do is what? Square root both sides, but don't forget to put plus or minus. Very good. Go ahead, everybody, try this. So did you all put square root both sides and put plus or minus on the right side where the number is, right? And what does the square root and the square do? They cancel out, so you just get x minus 4 equals to square plus or minus square root of 3, right? So right, and then what do we do? You add 4, and of course you get this. How many numbers does this represent? 2, so you write 2 of them like this. How many people got the 2 answers as you see here? Very good. Easy enough?
Yeah.
Okay. So so you might want to square root both sides when the left side is square. Sometimes they could get kind of creative, and instead of them giving you like x plus 4 squared, what might they give you instead of something square on the left side? They might give you a perfect square trinomial. So if If you want, you could write, if you have a perfect square trinomial and you recognize something like this, right? X squared minus 4x plus 4 equals 7. If you say a perfect square trinomial, you could just, right? You know that this is perfect square of x minus 2 squared, right? And get the answer that way. If you like, yeah, so on the left side, you see you have more space if you like, put it in there, right? There are two. So sometimes they could get creative here, like this, right? Instead of them giving you a binomial square, they could give you a perfect square trinomial, right? If you could recognize that's perfect square trinomial. Yeah. Give you time. Okay. So third method I'm going to talk about is completing the square. Okay. So when do you want to use completing the square method? If I have this form, what do you want the a to be? If you're gonna ever complete the square, 1. A has to be 1, right? So that's what I wrote down. When a is equal to 1 n, I wrote down b is an even integer. What do you suppose I said b is even when b is even? Yes.
You can divide it by 2.
Yeah, when you divide it by 2, you don't get some fraction. Now, if b is not even, could we still use the completing the square method? Yeah, it's just, if you're gonna do that, might as well use.
Oh yeah, so
Might as well use what? If b is quadratic formula, right? Because we have choice, right, of any choice of using it. So if b isn't going to be a nice even number, right? If you have an odd, you're gonna get fractions. So why not then just use quadratic formula then? So if b is even, you might just want to use, right? If a is 1 and b is even, might just want to use the completing the square method. Question?
so if it's 2/3 over 2, is it 2/3 times 1/2?
What are you talking about? What do you mean? Hold on. Do you have a specific question on?
Yeah. If it's 2/3 divided by 2 for
Yeah.
the
Yeah.
that formula, is it 2/3 times 1/2?
Yeah.
Because
Of course. If you're dividing something by 2, yeah, you're talking about how you get that number to when you add the two number
yeah.
square. Yeah, you b over b divided by 2 squared. So if it's 2/3, yeah.
Yeah.
Dividing by 2 is the same as multiplying by half.
Oh.
Okay, so something like this. Is this a good one to use completing the square method?
Yes.
Yeah.
Yes.
You have a1, b is 6. So what should I do first, by the way?
Add 5.
Add 5, so you gotta get rid of that 5. So, and then you see how when b is even, it's kind of nice. So Michael, what do you want to add both side by? Don't we have to add? Don't we have to complete the square on the left side? So what do we have to add both side by? 9. Where did you get 9 from? You're right. Where did you get 9 from? From Sarah?
Yeah.
Okay, I want you to go ahead. Think about this. I'll give you time. Why do we have to add both sides by 9? I wouldn't actually write 9. I would actually write plus 3 squared, right? Wouldn't that be better? Okay, go ahead.
Oh.
Okay, so Michael, why do we add both sides by 9?
Oh, because that's b squared.
Exactly. Your b is 6. B divided by 2 is what, guys? 3. Don't we want to add both sides by 3 squared? Both sides? That's how we got 9, right? On the right side, I just wrote 9. But I kept it as 3 squared on the left side, right? Because this becomes x plus 3, right? Doesn't the left side become perfect square trinomial? X plus 3 squared equals 2. 5 plus 9, so you get 14. Then what? You basically square root both sides. Go ahead, finish it up. Everybody. So did you all square root both sides like this? Right? Good, right? And then, of course, we subtract 3, so you get 2 solutions. Negative 3 minus rad 14, comma negative 3 plus rad 14. Easy enough? Okay. So if on the test, if I ask you to use completing the completing the square method, you gotta do it this way. It's a nice review. But if I didn't say anything, use any methods you want, and you're not quite sure if you forgot or if you're not 100% confident, could you just use quadratic formula? Yeah, you get the same answer, okay? A question?
On the test, if you toss to use completing the square method, will it be like a nice even
That's a good question. I'll try to do that. But you should be able to actually do this without it being uneven. Okay, so yeah, we'll see. We'll see. But you should be able to.
And it's easier to mess up.
Right, but you should be able to do it. Okay. Good question. Last we have the quadratic formula. When do you want to use this? When you for all the other, when you have for all the other cases, or if you ever get stuck, you could always use quadratic formula. So when all previous methods did not work, or you forgot how to do them, okay? Right? If you forgot to do any of these other ones, just use quadratic formula because this is going to always work, right? It just takes a little bit longer, but it's better than not doing anything, right? So, of course, you have to make it equal to what first? Make sure it has to equal to 0. If it doesn't equal to 0, right? This is a form you want, right? Let me actually write it down. So you want this form ax squared plus bx plus c equals to 0. And Michael, does a have to be 1? No. To use quadratic formula, as long as the whole thing equals to 0 and you know what your ABCs are, you're ready to go. And of course, what's the solution for the quadratic formula? What is a quadratic formula? A equals negative b. Okay, there you go. Yeah. You all know what. Okay? Easy? Does that make sense, guys? So you know, if you ever get stuck, you always have something to fall back on. Unless I ask you specifically which method to use. Yeah, exactly. That's why we gave you that. Okay? Any question? Oh, by the way, when you plug in, after you put... by the way, do you think it's a good idea to write down what ABCs are before you actually plug in? And do you think it's a good idea to use parentheses when you plug in? How many people have benefited from using parentheses where if you didn't, you would have put down some negative as possible? Yeah, please do that. Even though it takes just a second, okay? Just make sure you know what you're plugging in, and you know. Okay, very good. A lot of you benefited. That's good. Okay. So, any questions? Are we good? Okay, let's do some examples then. So the worksheet I gave you, example 1 says it says solve each quadratic equation using the most appropriate method. So if I gave you this, the first one, rather than actually doing them, I'm gonna give you time for you to do it, but 98, right? Which method? So let's think about which method we want to use for this one. What would you want to do for this one? You got 50x squared equals 98. Yes. What do you think? You think you want to factor? The left side?
Divide by 2.
Divide both sides by 2? Okay. Then you want to factor? Is this difference of squares? Okay, so if you saw that, then that's what you could use. Very good. Or, so someone was said divide both sides by 2. Okay, always simplify, right? And you would get difference of squared because you get 25x squared minus what? 49. That's the difference of squared. You could factor that. Or you could also move the 98 over to the other side and divide both sides by 50 and simplify that fraction and square root both sides. Right? It doesn't matter. Same. Right, okay. So there are many different ways. But would you use quadratic formula for this one? I wouldn't. Okay. So let's look at example 2. It says. I'll give you time. So let's think about which methods you want to use first. Then I'll give you some time. Okay, if you have 3n squared plus 10n minus 5 equals to 0, which method would you like to use for this one? I don't know if I want to use, because if you had to complete the square, you have to divide both sides by 3 first.
Yeah, no.
Yeah, probably not a good idea. I think I could use, you could use quadratic formula. Yeah. Square root both sides? Is this trinomial a perfect square trinomial? No. I would just use quadratic formula for this one. Unless you know how to factor that trinomial. Okay, if that trinomial is easily factored, what? Easily factored? If it's easily factored, then you could easily factor. Okay, what about example 4? 3. It says, so I would use quadratic formula for this. What about p squared minus 12p plus 3 equals to 0? Which method would you like to use? John, what do you think?
Actually, for number 3, we use the completing the square method.
Yeah, you could use completing the square method because your coefficient is a, your b is even, subtract 3 from both sides, and then complete the square. Or if you're not so confident in doing completing the square, you could just use what? Always fall back on quadratic formula. Okay. All right, example 4. So either completing the square or you could use quadratic. But if you know how to complete the square, it's easy, right? Example 4. What about r squared plus 9r plus 8 equals to 0? Then, which method would you like to use for this one? Yeah, just factoring. Isn't that trinomial uses a factor? Right? Your leading coefficient is 1, so you're just looking at what times what gives you 8, but when you add you get 9. 8 and 9. 8 and 1. Okay. Does that make sense? That's easy. Go ahead. Everybody try. I'll give you some time. Okay, how many people got number 1 answer as so how many people divide both sides by 2 first? Okay, you should always simplify if you can, right? There are 2 ways of actually doing this. You could either factor the left side because you notice that it's difference of square. Okay, and if somehow you didn't get that, well, you could always add both sides by 49 and divide both sides by 50, right? And if you simplify 98 over 50, you get 49 over 25. Then all you have to do is what, guys? You could also square root both sides, right? Then you get plus or minus 49 over 25, and you get the same answer. Any question? Should we put all the way down here like this? Does that make sense? Okay, who has the answer for example 2? By the way, did you guys use quadratic formula for that one? So the answer should be what? Who has that one? How about Jisu?
X equals negative 5 plus or minus 2 rad 10 over 3.
Yeah, 2 rad 10 over 3. Okay, you have to simplify that radicand, right? By the way, how many numbers does this represent? 2. So on the test, I would like you to separate them, right? Okay. It's easy. All you have to do is write this and copy this and paste it. Okay? And then make this one smaller. There you go. The 2 answers, okay? Alright, example 3. Which method did you guys use for that one? Completing the square method. How many of you used the completing the square method on that one? Very good. How many used the quadratic formula? No one? Okay. So good. You all know how to complete the square. What did you get? How about yes, sir? Yeah, 6 minus rad 33 or p equals to what? 6 plus rad. The others, I had the minus subtract. Smaller one first. Okay, any question? Okay, what about example 4? Which method did you use? Yeah. It factors. What's a factor to? You get r plus 8 times what?
R plus 1.
Yeah, equals 0. So exactly. Any question? Easy. How many people got all 4 of them right?
I did.
Good. You think you could do something like this for your homework and so forth? Okay, good.